Hey there, team. We're going to take a look at the example here for Hess's law calculations. We're looking at 5.65. We're given 3 part reactions, and we need to be able to rearrange them to solve for the net reaction labeled at the bottom. Let's go through our process here. So the net reaction here is we have C2H4, or ethene gas, plus 6 fluorine gas molecules are going to form 2 carbon tetrafluorides gas plus 4 hydrofluoric acids. So that's our net reaction. Let's look at reaction number 1 that we're given here. So reaction number 1 is that hydrogen gas plus fluorine gas will form 2 HFs. And this has a delta H equal to negative 537 kilojoules. Reaction number 2 is carbon as a solid plus a pair of fluorine gas molecules form carbon tetrafluoride, and our delta H is equal to negative 680 kilojoules. And our third part reaction, 2 carbons, solid, plus 2 hydrogen, gas. We're going to combine to form C2H4 gas. And our delta H is equal to positive 52.3 kilojoules. There we go. All right, so the first thing we got to look at here is we need 1 mole of ethene, but as a reactant, not a product. So this reaction, we're going to have to flip both the reaction and the sign of the enthalpy. We needed 1, this is 1, so we're good. Next, we need to form 4 moles of hydrofluoric acid, HF. This reaction only forms 2 moles of HF. So we are going to need to increase this reaction by a factor of 2. Then we'll get 2H2 plus 2F2 forms 4HF, the 4HF we need. Get that? Next, our net reaction requires 2 molecules of carbon tetrafluoride. This only forms 1. So this one we're also going to have to increase by a factor of 2. Then we'll get the 2 CF4s that we need in the reaction. So now, let's draw this all out. So we're going to draw reaction number 1 as 2H2 plus gas, state of matter matters, gas, but this is now going to be, our delta H is going to be negative 1,074 kilojoules. You double the reaction, you double the enthalpy. So for question number 2 now, I'm just putting that little prime there to say that I've modified it. This has to be doubled as well. So now we've got 2 carbons, solid, plus 4 F2 gas, are going to form 2 CF4 gas. And our delta H will be equal to negative, oops, page is moving around on me there, negative 1360 kilojoules. So again, you doubled the reaction so that the net reaction and your part reactions here would line up. But if you double this, you got to double this. All right, our final reaction. This one here, we had ethene gas as a product, but we need it as a reactant, so we had to flip the reaction. So that is to say that C2H4 gas would decompose into 2 carbon solid plus 2 hydrogen gas, and the delta H, instead of being a positive value, would be negative. Now, let's add everything together here. Okay, so here we've got 2 hydrogens as reactants, 2 hydrogens as products. Here we've got 2 carbons as a reactant, and here we have 2 carbons as a product. So we'll cancel out anything that's both on the reactant and product side, or reduce. What's left here is we've got C2H4 as a gas, plus 6 fluorine gas molecules. So we sum together all of our reactants. We sum together all our products. So here we've got 2 molecules of carbon tetrafluoride and 4 molecules of hydrofluoric acid, or hydrogen fluoride gas. This is this, so you know you've done good. Now we just have to sum all these together. Do I have a calculator? I don't feel like adding this in my head right now. All right. 2, 6, maybe I'll just 11, 18, carry the 1, 4, 2, negative. I think that math works. You might want to add those up just to be sure. That would be great. I'm looking at this and I'm thinking, yeah, I think that should be good. All right, hopefully that walks you through Hess's law. Change the part reactions by factors so that they line up with your net reaction. If they're on the wrong side of the equation, you got to flip that equation so that the reactants are products, the products are reactants. But if you flip it, you got to flip the sign. If you increase by a factor, these have to increase by a factor as well. All right. Good luck.